Hello and welcome to the feature of the week. Mixtures of models are useful to represent subpopulations of individuals with different dynamics, for example, responders and non-responders to a given treatment. Here is such an example where we see clearly the difference in the outcome measured in the data. It seems that the responders' data can be captured with an exponential decrease, while the non-responders' data seem almost constant. In the feature of the week number 27, we showed how to model such subpopulations with the same structural model, but with individual parameters described as mixtures of distributions. In this video, I will show how to model subpopulations of individuals with different structural models. But let me first give a brief recap on using mixture of distributions to have a clear overview. If the status of each individual is known, mixtures of distributions are defined with a categorical covariate effect in the statistical model. For this example, group cat is the column tagged as categorical covariate, and a single equation of exponential decrease is used to model all individuals with a baseline parameter A and a slope parameter K. A covariate effect of group cat is added on A and K. The estimated population parameters with the covariate coefficients define different population distributions of A and K for responders and non-responders, based on different typical values, but with the same standard deviations of the random effects. Estimated values of K for non-responders in blue are very small, leading to almost flat predictions, as shown here on the individual fits colored by group cat. Now, if the status of each individual is unknown, a latent categorical covariate can be used to perform unsupervised classification. Since there is no covariate in the data, the latent covariate, named by default LCAT, is created instead in the Statistical Model tab, with the same covariate effect on A and K. The probability for some individual of being responder or non-responder is estimated with the parameters PLCAT1 and PLCAT2, which sum up to 1. And the most probable category is available in the plot to stratify the two groups. Again, for more details on latent covariates, please have a look at the feature of the week number 27. In some cases, describing the two groups of individuals with the same structural model might be irrelevant or impossible. In that case, we must define a mixture of structural models. In this video, I will show in detail how to do this. In our example, instead of using the same structural model with mixtures of distributions on the parameters, it could make more sense to describe the non-responders data with a different structural model as a constant. The data from the two groups will depend on different parameters, on the parameter A1 for non-responders and the parameters A2 and K for responders. If the subpopulations are known, the status of each individual can be read in the model as a regressor to choose the correct equation. This is what is done in the monolithic demo named BSMM1 project. The group column is duplicated because monolithic uses it both as a regressor, read in the model to distinguish responders and non-responders, and as a categorical covariate to stratify the diagnostic plots. Note that the regressor column should contain only numeric values, while the categorical covariate column could also contain strings. In the structural model, the group column is read in the variable j with this line. Then the value of j is used with an if-else statement to choose the correct equation. In check initial estimates, the predictions for each individual depends on its group and uses only the parameter A1 for non-responders and the parameters A2 and K for responders. The three parameters A1, A2, and K can then be estimated as independent distributions. Even though individual estimates of these three parameters are given for each individual in the results, the values of A1 can be ignored for responders as they have no impact on the predictions for these individuals, and similarly, the values of A2 and K can be ignored for non-responders. The covariate is not used in the statistical model, but can be used to stratify the diagnostic plots, for example here to color the two groups in the individual fits. We see that non-responders now have constant predictions. Now, if the status of each individual is unknown, Unsupervised classification is also possible by estimating a random between-subject mixture of structural models. This is what is done in the monolithic demo named BSMM2 project. In this case, there is no information on responders or non-responders in the data. In the structural model, the two equations are defined in the variables f1 and f2 and are then mixed into a single variable f with the function BSMM. BSMM stands for Between Subject Model Mixture, and it defines a random mixture of structural models such that the structural model for a given subject is f1 with a probability p and f2 with a probability 1 minus p. P is a population parameter of the model to estimate and corresponds also to the fraction of non-responders in the population. Note that several BSMM functions can be used in the same structural model with a common probability p or with different probabilities. However, they define independent model mixtures. In addition, the output of BSMM, here f, cannot be used as part of a further equation, but must be used directly as output of the structural model. In check initial estimates, the predictions for both f1 and f2 are visible on each subplot with different colors. The initial estimate for p is not used for these predictions. In this model, all the subjects have the same probability of being a non-responder, so p is defined without inter-individual variability. But it is constrained between 0 and 1 by selecting the logit normal distribution. After estimating p with the other population parameters, the most probable group for each patient is also estimated. This results in a classification that is available in the table of individual parameters in the result folder in the last column named BSMM Y1, and also for stratification in the diagnostic plots. Now you know everything about modeling different dynamics in subpopulations of individuals. See you next week for another great feature of the Monolith suite.